Hey, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ikram bin Rashid. My cabinet number is DF210019. I'm from a group 2. So group 2 have 5 members, which is including me. Oh, before that, I'm from section 1. Okay. So my part is about introduction. So about this project, we are design a spherical design for water tanks. Why we design a spherical water tank? Because it can hold stress-wise as tori spherical and hemispherical tanks. This kind shape can easily lose heat to fluid over than normal water tank. For the aim of the project is to put in a round tank that can hold enough water to make sure a small tank always have enough water. So to design this, we use a bisection method and Newton-Raphson method. So about the problem statement, one of the problem statement that we got is the company of our civil engineer is want to build a circular tank with a 3 meter radius that can hold up to the 14 meter cubic of the water. So the company has to figure out how deep the water has to be. So by using this formula that I show you, this V is a volume, pi and H over 2 exponent 2 and 3 are deduct with H and 3 exponent negative 1. So using this formula, we can get H, the depth of the water. So so the aim of the objective is in order to construct a spherical tank, it is necessary to implement a system of nonlinear equation and a specifical the bisection method and Newton-Raphson method. So second is to examine the similarity and difference between the bisection method and Newton-Raphson method. So when we know the difference, we can use an accurate number to build a spherical water tank. So that's all for me. Thank you.
Okay, this is the filler table. I will conclude of this filler table. We have three facts, which is the volume of spherical tank is 40 meter cubic with the 3 meter radius. The second one, the water holds by spherical tanks. And number three, the civil engineer need to build an accurate water level of height. So these facts we will do the action by using the first formula, which is the volume of circular. The second one, we use the bisection and Newton methods. And the last one, we need to find suitable height of spherical tank to build. So from there, we should do calculation to find the solution of our problem. Hi, my name is Muhammad Zahir bin Abdul Rauf. I will explain to all of you about the literature review in this project. After doing the past research of the numerical method and civil engineering problem, according to the Kappa and Kenos 2010 sixth edition of numerical method, studying numerical method solution to civil engineering problem is crucial because there are several goals researching numerical solution in engineering. The second fact, according to the Wiley and Son 2018, one of the features of numerical method solution is using trial and error. So in this project, we use Newton-Raphson method and bisection method to be employed to solve the problem. Okay, next part, which is methodology. Methodology in our project, we are focused using three main formulas, which is volume of circle, bisection method, and Newton-Raphson method. By using volume of circle, we find the volume of the tank. And bisection method, Newton-Raphson method, we use both method to find the intersect point. The procedure of bisection method, we should check the root by take 2 points, either the point have at least one root. After that, we produce the table to find the final answer until the limitation reaches epsilon equal to 0.0005, and then we move to the next method, which is Newton-Raphson method. The procedure almost same. Take the root first, and then we produce the different table to find the final answer and its limitation, which is 0.005. After that, we will compare the answer either it's close or not.
Hi, my name is Muhammad Ilyas. So let's continue to the calculation. So in this case, we have the two calculations, which is bisection and Numerical method. So from the spherical tank formula, which is here, and then we substitute to the design, which is 3 meter radius, and then we expect to fill with the 40 meter cube of water, and then we come up with this function of hash. After that, we're going to check the IVT to find the exact, to find the approximate root. We take 2 and 3. So that is a root between 2 and 3. Okay, for the bisection method, we have to tabulate like this to find the approximate root, which is between 2 and 3. And then we are using the FH formula, which is this, and apply to the stopping criteria, which is epsilon 0.005. And then we got the answer for the root is 2.4073. Okay, continue to the Newton-Raphson method, which is we have to simplify the f hash function and then derive it to use in the calculation of Newton-Raphson method formula. Okay, we check the root in the calculator for the equation is between 2 and 3. So let's say we take hash is equal to 2 and then substitute to the function f hash and then f prime hash. Then we're going to use the formula of the Newton-Raphson method. Okay, let's take hash equal to 2 and then we're gonna find the answer until the true I, which is 2.4070, and then we try to the another root, which is 3, and then we got the I equal to 2, and the answer is also the same, which is 2.4070.
Hello, hi, my name is Muhammad Izzat Bizami. My mention number is 210030. So for discussion, from this project, I want to talk about the discussion. So from discussion, we know that we want to find, in this project, we want to find the height of water where the spherical tank is volume at 40 meter cube. So before that, we need to find the range of root, where the root is exists. So we found the root is exists between 2 and 3 meter. So that we use a bisection method to determine the height of water and Newton-Raphson method to compare the value. So from the bisection method, we use the epsilon to complete our iteration. So our iteration is stopped at C10 where the root is 2.4070. So for the iteration, we also use the same condition where the iteration stopped at 0.005, which is 2.407 as max root. So we got the two value to compare it. So I think that's all for me. Thank you.
In this project, the Newton-Raphson method and the bisection method has been applied to determine the root of the polynomial problem. The bisection method divides the interval repeatedly to approximately determine the root of the given equation. Then the Newton-Raphson method is used to identify the root of the linear equation, which is a root finding algorithm that offers both speed and simplicity. So in conclusion, in this project we learn how to use numerical method to solve the real-world engineering problem. The numerical method are procedures that can be used when the analytical method are not easily be done, and the mathematical issue is associated with the engineering analysis. That's all from us. Thank you.